Hello everyone, welcome to another episode of Build Sunday. This is our third episode. In the previous episodes, in episode 1, we have seen how we can build a chat QA application using simple APIs of existing proprietary models like ChatGPT, Grok, and other models. After that, we have seen a concept in AI engineering which is known as RAG. And in that, what we did is in the previous episode, in episode 2, we have built a simple document QA application, right? What it does is you upload a document in that whatever the UI we have provided, right? You upload that document, and after that, that document will go to a database. We call this database as a vector database, and after that, you can ask questions related to that particular PDF. We have built that application in episode 2. You can check both applications, which is provided in description and comment box as well. But the thing I'm trying to tell is in episode 2, we have unlocked one of the most critical concepts of AI engineering, which is RAG. And in that, we have just touched the overall, like very basic, we had a very basic understanding of what is RAG and why do we use it and all. Now, what I'm trying to do in this episode is we will build a much more better application than document QA. We are going to build a AI clinical support application where doctors can come and put their queries, and whatever the answer which is getting generated will come from backed sources. And while we are building this, I want this episode to be a complete A to Z understanding of RAG. If you are here watching our episode, then I want you to have a by the end, my goal is to give you the complete knowledge transfer of what is RAG, types of RAG. You should have in detail understanding, and you should be in a place that if you want to build RAG application, you can do within hours. Okay, that is my goal. Now, what I'll do is that let me quickly, I'm sharing my screen, so I'll go to Chrome here. Let us talk like the idea of episode 3 is to build a AI clinical support application, right? I might write spelling mistakes, forgive me, it's all right. People make mistakes, it's good. Okay, that is the main intent. Before going to the crux, before going to the inner part of the idea, let me quickly come back and see how we are going to build it. We are going to build this AI clinical support application from a concept which is there in AI engineering, and the concept name is RAG, right? The full form of RAG is Retrieval Augmented Generation. Okay, Augmented Generation. Now, what I want you guys to do is that, like, if you have notes or paper, just pull it out, start writing what are the things I'm writing, because this is going to be the most critical part of the entire video. Okay, now let us try to understand what is RAG, what is Retrieval Augmented Generation, and after having in detail in-depth understanding of what is RAG, I will talk about why do we even use it in the first place. Okay, so RAG, the concept of RAG is to avoid LLM uh, to generate answers on its own. What I mean by this is that in RAG systems, what we do is we will give LLM context, and we put some rules, we create some rules in such a way that the LLM has to give answer from the provided context only. So from the provided context, answer generation will happen. LLM, large language model, whatever it is, it can be GPT, it can be Anthropic, whatever the LLM model it is, LLM will not use its own brain. Instead of generating answer from its database, it will go to the context, right? It will go to the context. That context can be a set of documents, that context can be a set of video files, audio files, whatever it can be, right? It will go to that particular context which we have provided. I will talk about in detail what is context and all, but the idea is that from this context only my answer generation will come. I hope you're clear. Now, RAG has two main components. Talking about components of RAG, RAG has, if any type of application which is built from RAG can be broken down into two fundamental parts, two fundamental blocks, and these two fundamental blocks are really important to understand. Okay, so talking about like the blocks of RAG, first component is knowledge base creation. Knowledge base creation. Okay, this is first component. Second component is query processing. Okay, I will talk in detail what is this knowledge base creation and all query processing. So I have told you, right, that in RAG, our main idea is that LLM should not use the data it has. Instead of using its own data, we want our LLM to use the data which we have provided. Now, to provide this data, this curated data, we need to do some operations. We need to use some methodology, right? Because like this is our, for example, imagine, I'll give you a real-time example, that imagine that there is a firm. For example, I have opened KPMG, a family global business. I'm studying that as a personal project. But KPMG has their own data, right? There might be confidential documents, there might be some policies related to HR and executives within the company. So for company to company, the data might differ, right? So what they can do is that they can gather all this document, put that in a database, right? Put that in a database, and this database creation is known as knowledge base. This will be the knowledge base for the application that the company is creating. I hope you have understood. For KPMG, if they are building their own AI chat application, then whatever the documents they have gathered, HR documents, policies, like executives documents, all the documents they have gathered and put that document, or they have put that document in one place, in one database, that thing is known as knowledge base of the application, the RAG application which they are creating, right? That this accumulation of documents will act as a knowledge base for the entire chat application. Okay, now let us talk about like how are we going to what are the things involved in the knowledge base creation. Okay, let's try to understand step by step. Okay, so in knowledge base creation, I hope you have understood the definition of knowledge base. Knowledge base is a place where you can find the entire knowledge, entire data of a particular application. If we are building our our case, we are building AI clinical support platform, right? So for AI clinical support platform, the all the place where we are going to store all the medical information is going to be our knowledge base. And how are we going to create the knowledge base? Okay, if I talk specifically for AI chat application, we might divide our data. Okay, let me talk about like let me write the definition first. The definition is that a place where we can find all the valuable data valuable data for that application, for that product, right? If KPMG is creating AI chat application for their company, for them, then the knowledge base, all the documents of KPMG, the place where they are gathering, that will act as a knowledge base for them. For our case, we are creating AI clinical decision support platform, right? So the place where we are going to store all the medical documents, right? All the medical data, right? That place is going to be the knowledge base. Okay, knowledge base. Okay, now talking about data, right? Data can be of various forms, right? Data can be in the form of a video, data can be image, right? Audio, it can be text data, right? Text data, image, right? All these different forms of data we have. These are the different states of data, right? Video is one form, image is one form, audio, text, like this. To simplify, I don't want to take I don't want to take like I don't want to make this video 1 hour 2 hours long, so I'll try to make it quick, half an hour 45 minutes, something like that. So for our case, I'll take text data. Okay, and text data, where we can get the text data of medical world, right? One is websites. They are curated websites like uh, PubMed. PubMed is a popular website for to gather all the research papers which is being published in medical world. You can see that website. So one source of data gathering, one source is URLs, right? Curated medical websites, curated medical websites, right? This is one form, or you can say one way of getting text data for our medical application. Now the second way can be from PDFs directly. They are like, if someone is studying MBBS, they have PDFs, they have books from which they learn stuff. So what we'll do is that we download these books and we give that to our models to store data in one place, right? I'll talk about that in detail. So talking about data for clinical platform, for our clinical platform, if we are only focused on text-based data, then text-based data is of two forms, right? One is from URLs, from websites, you can scrape data and do all the things, and after that from PDF. Okay, so in PDF, I will start off with PDF. So what we do is that I'm telling you like how we are going to create knowledge base. First, we have understood that RAG has two components. One is knowledge base, second is query processing. After that, what we are trying to do right now is that we have understood what is the meaning of knowledge base. Now we are seeing how we can create our custom knowledge base. Okay, now I have PDF. Now what I'll do is that there are some tools which is text splitters. Okay, using text splitter, what I will do is that I will break the characters in the given PDF. Let's say I'm creating a chunk, groups of characters from 800, right? The let's say, for example, I'll give you an example. Imagine that this is a PDF. Imagine that this entire thing is a PDF. Now what I'm trying to do is I will give my data to my code base, and what my code base will do, a Python code. Imagine that I have created a Python code, and what this Python code is doing is that it is reading characters. Okay, and just imagine that from here to here there are 800 characters. When I hit 800 character mark, I will create chunk. I'll group those set of characters, let's say character 1. Similarly, I'll go from 1600 characters, sorry, from 800 to again 1600, 800 leap. So this will become my chunk 2. Like this, I will create chunks of my given PDF. Okay, and these chunks are based on number of characters. Understood. Now after creating chunk, let's say I have 10,000 chunks, right? 10,000 chunks, and in each chunk I'm storing characters up to 800 characters, right? Each chunk, C1 will store 800 characters, C2 will store 800 characters. And why are we creating chunks? You need to understand that you cannot, let's assume that you have a PDF. That PDF is of 10,000 pages. Now just imagine, can you give this 10,000 PDF document to a LLM? We can't. If we, even if we can, the token size will not be enough. Like LLMs have something called as context window. If that context window, let me tell you in very simple terms, that context window is something you can imagine, or you can understand the meaning of context window in terms of limit, right? LLMs have certain limit, like they cannot read stuff, they cannot go behind that limit. Okay, and talking about the recent model of Anthropic Fable 5, right? Fable 5 has 1 million token size, right? It has a 1 million context size, I believe, right? So it can read up to 1 million words at once. So a given book might have words more than 1 million. right? If they have more than 1 million characters or words, then LLM can't take that. It will go out of context. That is why we are segregating. We are creating chunks. We are segregating the given PDF, this large PDF, into small segments, and we call this small segments as chunks. Okay, after creating chunks, what we will do is that we have chunks. Now there is something called a sentence transformer. Okay, sentence transformer is a machine learning model. Using sentence transformer, we take these chunks and we convert these chunks into embeddings. Embeddings are nothing but you can imagine them as arrays. We will create n number of arrays, A1, A2, A3, and in this arrays we store all the words. Like we store chunk 1, chunk 2, chunk 3, like this. We store whatever the words, like 800 characters will be here, 800 characters will be here. Like this, we convert the English language. If the data is in English, then we convert the English language into its equivalent numbers. Converting a language, a human understandable language, into numbers. This process is known as embedding. Right? Now, after converting this into embeddings, what we will do is that we will have a database. A database is basically a place where we store this embeddings, right? And there is specific term that AI engineers use, which is vector databases. Right? What are vector databases? For example, if you remember, we have SQL, we have MongoDB. To store unstructured objects, we use to store unstructured data, we use MongoDB. Similarly, to store data in the form of tables, basically rows and columns, we use SQL. Similarly, to store data which are numbers, basically vector database is bunch of numbers, right? To store those numbers, we use a different type of database, and we call that database as vector database. And they are different vector databases like Qdrant, uh, ChromeDB, right? And FAISS, right? These are the different vector databases that we have. And let me write it here. In next episode, I am going to talk about vector databases in detail. That is the plan, right? After completing this, we'll go and study vector databases in detail. Okay, now I hope you have understood that. With PDF, what I'll do is that I'll take the PDF, break down into different chunks, take those chunks, convert that into embeddings, and store them in a vector database. Clear, very easy to understand. Now let's assume that I don't have PDFs, I have websites, right? Like this, PubMed might have different things. For example, if I go to cancer section, for example, you can see here. Okay, this is one paper. It is a medical paper talking about expression of NFKB, ER, FG and all, right? I don't know what they are, but it's a paper, and you can see I don't have PDF as such. Okay, I have just HTML page. Now what I will do in that case is that I use a tool called as Beautiful Scoop. Okay, what Beautiful Scoop will do is that first of all, I will scrape websites. Okay, I will scrape the given website and then extract the HTML content. Right, if you see every page, let me quickly inspect and show you. So here you can see that if I inspect, this is a text chunk, this is a text chunk. Like this, everything can be, like, you can get the data of a particular web page by scraping it. Okay, you can get the author's name, the abstract, whatever present on this page, you can get that from the HTML content of it. Okay, now I will extract the HTML page, and then after extracting, what I will do is that I will remove noises. I will remove noises. What is the meaning of noise? You need to understand that in RAG, the most important piece is knowledge base creation. You cannot compromise on knowledge base. Okay, now in a given page, they can be unnecessary things. For example, I don't need this, right? I don't need this thing. And here, I don't need the footer as well. Why do I need social media, LinkedIn, and all the profiles of this? I need only the main content. To get the main content, we need to remove the noise. Like for example, HTML tags, I don't require, right? I don't need uh, a header, right? I don't need footer. So what I'll do is that I will filter them out. I'll remove them out. After removing all the things, I'll get text data. And then after getting text data, I'll perform the same thing, creating chunks, embeddings, arrays, and the same process that I did. So this is how I create my knowledge base. I hope you have understood. Now let's talk about the query processing. Now this is the second fundamental block of RAG, which is query processing. So in query processing, what we do is that, let's say, let me walk through from a user's perspective, right? So let's say I have a query, okay? User has given me query. What I will do is that in step one, I convert this query into numbers. And what did I say to you? That converting a user query into numbers is known as embeddings, right? Embedding or tokenization, you can call both words. Both words can be interchanged based on the context, okay? Now, after converting them into numbers, what I will do is that I will go to my vector DB, okay? Just imagine that I have given a query, hello, what is cancer? Or just let me remove hello, I have given what is cancer, right? Now just imagine that cancer word is 102. Like in tokenization, what happens is you're converting words into tokens, okay? And you will get word as, let's say, 101, this is 105. Now what I will do is that I will go to my vector database, I will search the similar documents based on the query, right? Search similar documents which are very near to this numbers, whatever the numbers which are near to the in the vector database, I will gather those those documents, right? I'll gather the similar documents, and in step 3 I will re-rank these documents, re-rank the document based on the higher similarity. Let's say my query went to my knowledge base, and from knowledge base I got 20 documents which are similar and relevant for the given query. Now what I will do here is that in order to increase the accuracy, I will sort the given documents in ascending order. This is known as advanced RAG, right? We have different types of RAGs, but I will talk about that in detail. But let me tell you that after getting documents, I'll sort them in ascending order, and the first document which I have will have the highest probability, highest similarity, right? Relevancy. Now after re-ranking the documents, I will create the context. Context contains my prompt template, right? I will create something called as prompt template. Prompt template is like the set of instructions which I am telling to my LLM that you should not generate answer from your brain, don't use your own database. All the rules and regulations which I'm telling to my LLMs is known as prompt template, or it is mentioned in prompt template. Plus uh, along with prompt template, I'll pass my query plus the documents which I have extracted. After getting all these things, finally I will give the context to my LLM, and the LLM will generate answer. I hope you have understood what we do and how we do. This is how the RAG application works. Take any RAG application. This is the two blocks. One is knowledge base creation and another one is query processing. Now let us try to understand what are the different types of RAGs we have. right? RAGs, they are like different types of RAGs. For example, one is simple RAG. Simple RAG is basically give a query, I will go to knowledge base, extract documents, give context to LLM, right? And you get the answer. Like the overall architecture which I have shown you, the entire concept which I have shown you, you can categorize that as a simple RAG. Okay, that is one type of RAG, right? Now the second type is advanced RAG. In advanced RAG, what we do is that there are two stages. One is pre-processing. Okay, after that, second one is post-processing. In pre-processing, what we do is that before even going to LLM, we rewrite query. We enhance it, right? All the things we do, like before even touching LLM, before even touching our vector database, we try to understand what exactly user is trying to ask, and based on the understanding we have, we increase the like clarity of the prompt by mini LLMs. We use SLMs here. SLMs are small language models. Like we use small, teeny, tiny models to enhance the query that they have provided. After that, in post processing, we re-rank the like documents, and we sort the documents out and give clear instructions to enhance accuracy and all. That is the second type of RAG. In third type, modular RAGs. Okay, modular RAGs are a combination of RAG plus deep learning models. For example, if you take DeepSeek, right? I'm just taking an example, right? DeepSeek have the capability of web search. They have the capability of deep thinking, right? Now, let's say you want that capabilities inside your application, inside your AI clinical support application, right? Now, to include this along with RAG, we call this as modular RAG. For example, let's say user has asked a question which is somewhat, let's say 50% is in our vector DB, is in our vector database, but we don't have enough context. Then what we will do is that we do a web search, get that data, get the remaining 50%, and give this and this to LLM, okay, and generate answer, give answer to the user. So in order to uh, give more enhanced responses, use this modular RAG based on the thing. Like we give clear instructions that when to use deep thinking, when to use web search, all the things. Okay, so these are the different types of RAG, and this is the overall concept of RAG. Now let me talk about why do we even use it in the first place. The reason why do we use RAG is that, first, to remove hallucination. Let me write this with a red ink pen, right? Why do we use it? Okay, so talking about why, one is hallucination is one of the biggest problems that uh, this large language models face. If you keep on asking questions like give me this, give me this, give me this, even though it's a false information, it will give you the false information. So that is one thing. And second is source back answer. In medical world, in tax world, it is really important to have backed information. Every word, every sentence should be backed by the source, the research papers, right? So these are really important. In RAG, you can exactly tell from which document the answer is coming from. And the third is uh, accuracy of answers, right? To give accurate responses to clinicians, to finance firms, you use this. These are the three major uh, reasons why do we use RAG in the first place. Now let us talk about our application, right? So talking about our application, our goal is to gather, first let me write this with uh, green or else white, black, black. Okay, now the goal is to gather all medical data, and this data can be from websites which are URLs or PDFs. We give this data to our vector database, and the goal is that whenever a clinician comes in and asks questions, that answer should come from the knowledge base which we have created. I hope you have understood. This is what we are going to build. And talking about the tech stack, let's talk about the code, and directly we'll go to our IDEs and build the application. Now, talking about the code architecture, right? Let's dive into coding. My app will be divided into two folders. One is UI and another one is AI, right? UI will hold all the code of UI front end. Okay, and I'm going to use React White here. Okay, now in AI I will segregate each process. For example, I have crawling process, like I'm going to websites and getting data. That will be in ingestion folder. Ingestion is nothing but getting data, inserting data into our vector database, and after that I'm converting documents into numbers and then storing it in vector database. That thing is known as embeddings. So I will create a folder called as embeddings. In embeddings I'll store all the process of re-ranking, converting vectors to numbers to vectors, vice versa. Now I will have another folder called as core will have all the configuration, like which model you are going to use and all that stuff. After that, generation is a folder which is responsible for generating answers, and in this only our LLM will be there. In this folder only our system prompt will be there, all the stuff. And after that, API will be the entry point for all these documents. So this is my structure, this is my code structure. Now what I will do is that I will open ChatGPT. I'll tell my idea, right? What are the sources I want, what are the things I want, right? And I will ask it to give me prompt. I'll give whatever the prompt it give to IDE, and then I'll see the responses. This is my thing. So let me quickly stop screen for a moment and let me give the prompt here.
I want to create a AI clinical support platform using RAG. The idea is that my application is going to divide into two parts. One is UI, where a folder, the UI folder will have all the UI stuff, and I want to use React White. And the second part is going to be AI folder. In AI folder, I want a different folder for embeddings, different folder for ingestion, right? Let's say I have a URL. I should be in a place where I can pass a URL or PDF to a particular, like my code, and it should ingest the data. So ingestion is responsible for that. Configuration, all the configuration code folder will be there. For calling all the different folders, API folder will be there. And also generation folder will be responsible for generating answers. Embedding will be responsible for generating embeddings, like re-ranking and all the things. And I want to use sentence transformer, cross encoder for re-ranking, beautiful scoop for scripting, and I want to use a local LLM, right? Ulama based LLM, which is installed in my computer. That is the thing I want to use. And for Qdrant, I have downloaded Qdrant locally, so I want to use Qdrant locally in my database. These are the things. And my goal is I want you to give me a complete master prompt, which I can give to anti-gravity to generate the code. And remember, I want it really fast. I don't want any login or authentication and all. I just want chat interface where I can chat immediately, because I'm giving a demo on YouTube, and I want the application to run quickly and I can show. But remember, the UI should be there. I got the prompt from ChatGPT. This is what it has given me, right?
Like you are an expert AI clinical AI architect and senior software engineer, blah blah blah. I don't want any authentication and all, right? Modern UI and all. So this is the thing. And if I give, I'm using different models here. You can use any of the models above. I can use Sonnet and all, but for now this is I want this to happen quickly, so I'll just give enter. Right, I'm using a very small Gemini model. I can use Opus, Cloud Sonnet. These are bigger models. If your task is big, then you can use those models as well, right? But just let it code. When the code is completed, we can cross verify the code as well. So yeah, let's wait for a while now. Just for your information, guys, in next upcoming lectures, the third Bill Sunday, this is the third Bill Sunday episode. Fourth Bill Sunday episode is going to be on vector databases, and in from fifth episode we will see agentic based application, how we can build agents and all. It's going to be really interesting. I'm trying to make content at once because I don't have much time. I'm working in thousands of things at once. So yeah, I really want to provide the best value for you guys. That is my goal. Right now, the IDE is building application. I'm just waiting for it to complete. Okay, so I got the application working. I waited for 15-20 minutes. It gave me the complete code. It gave me some errors. I rectified those errors. But yeah, the application is working. Let me quickly give you a brief. Uh, Okay, so this is the clinical AI application. In that we have two folders, AI and UI. AI is responsible for all the AI stuff like embeddings, configuration, re-ranking, generation of LLMs and all. UI folder is basic React to it application. Okay, so I'm running the application right now, and I have tested it as well. You can see, right? I have tested few things here. Now what I'll do is that I'll quickly refresh this and delete the existing stuff. I have deleted the thing. Now, in the UI, if you see, I can do two things. In the UI, I can do two things. One, I can upload a PDF and ask questions related to that PDF, or I can give URL of a particular thing. And from that URL, I can ask questions, right? And what happens is that whenever I'm giving something, okay, okay, I was not sharing my folder. Really sorry about that. Okay. Uh, AI folder responsible for all things. UI folder is responsible for UI, and I'm running my application. This is my application working. Okay. Now here, if you see the UI, sorry about that. If you see the UI, we have dark theme and light theme, and I can upload a PDF, right? And after uploading PDF or giving URL, the what are the data present in those PDF or URL website, I will go to my vector database, and from vector database I'll get answers. So this is how the RAG application works. Let me quickly give you a demo, right? I have my Wikipedia page about a particular drug. I'll copy this. I can't pronounce the drug name of course, and I can give URL plus. Now what happens is that that data will be scraped and ingested into my vector database. Now I have a query, right, related to that particular information. What precautions should be taken when taking lisinophyll and spring guide, whatever. I can't speak that, can't pronounce that. But yeah, I'm pasting it here, and what happens is that my query first of all will go to the knowledge base which I have created, and then I'll get the answer. So the reason why we are not getting, let's wait for a few minutes. I hope we should get the answer. I don't know why it is like it has searched for sources. See, so yeah, let's see in terminal what is happening. It is initiating Olama model, right? I'm using Olama model and all. And when it comes here, okay, then my answer will come. I can see re-ranking 8 candidate queries, re-ranking complete, selected 4 items. So all the things which I mentioned is happening there. So let me quickly see. So you can see the answer is coming now. As the answer is generating, I'm getting the answer. So yeah, yes guys, this is the application working. I hope you have learned something. After getting answer, I'll stop my screen share and I have a few things to talk. Precautions with lensophile and sprinocolotin when taking both lensophile and then several precautions should be taken. Additional consideration, dental care. Yep, yep. I hope you got the point. Like I'm getting answer. This is the application work. You can ask a number of questions to it. So yeah, one thing, you'll find the entire code base in GitHub, right? You can access my GitHub and clone it, put it in your resume. But before putting, I want you guys to have a complete understanding. And in the next upcoming sessions, we are going to talk about in episode 4, we will see vector databases in detail, how they work, what is the different types, which one is the best vector database and all. After that, we will go into a more interesting topic, which is agentic application. So I hope you got the point. Let's see we got the complete answer or not. Yeah, we got the complete answer. I hope you got overall working of the application. Now stop screen share. Yep. So thank you everyone. Thank you for watching till here, giving your 1 hour and learning new stuff. I hope the best for you guys. So with that being said, thank you for watching. Bye. I'll see you in the next one.